The Lord of the Rings, my favorite franchise ever, is having a bit of a moment right now. There's reports of a new video game. There's a new film in the works. Anyone else excited about this? Hello and welcome to another episode of CNBC's The Tech Download. I'm Arjun Kharpal, Senior Technology Correspondent here at CNBC. Why was I talking about Lord of the Rings? Well, because the focus of this episode is Anduril. Anduril is a legendary sword from the Lord of the Rings, and you'll hear a bit more about that in the episode because I'm speaking to Brian Schimpf, who's the co-founder and CEO of Anduril. Now, Anduril is a defense technology company. If we think about the last few decades, defense industry hasn't changed at all, really, very much. It's dominated by a few big players building highly complex, very expensive systems over long periods of time, often costing billions and billions of dollars. But that model is really now being challenged by a handful of startups that are popping up, a new generation of companies really mainly coming out of Silicon Valley with that Silicon Valley mindset of trying to rethink how the technology is built and how it's being deployed. And instead of focusing just on building hardware, which is obviously a key part of the equation here, they're focused on the software side, artificial intelligence, and how to manufacture this kind of product cheaply and quickly as well. No doubt, it has been a state of geopolitical flux. There have been multiple wars around the world, and we've seen during those conflicts that the nature of warfare itself is also changing from these large, expensive platforms to more nimble, cheaper, smaller, and faster, at times autonomous systems. Conflicts in places like Ukraine, for example, have shown just how important things like drones, data, speed have become. All of this really is pushing defense closer to the world of technology and where iteration, faster iteration, software, scale, all matters a lot. And that's really where companies like Anduril come in. And as I said, today in this episode, I'm speaking with Brian Schimpf, who's the CEO of that company, about how they're trying to reshape the defense industry and what the future could look like in an age of AI. Brian, thanks so much for joining me on the Tech Download.
Hey, thanks for having me here.
So Anduril, Lord of the Rings fans out there, Aragorn's sword in the Lord of the Ring, forged from the shards of Narsil, the blade Isildur used to chop the ring finger off of Sauron.
Yep.
Why the name?
Well, we're all nerds, and the Lord of the Rings theme is very rich. But the sword, Anduril in Elvish means Flame of the West, which we thought was a pretty good and appropriate name for what we're doing.
Yep, and we'll get into why. Do you have a favorite? I mean, Tolkien named a lot of things. Everything from the horses to the trees. Do you have a favorite sword in the? Is it Anduril?
I think it would be Anduril. Would be the favorite sword. I mean, I'm not a huge expert in all the swords, but
it's up there. It's definitely
up there. It's way up there.
Mine is Glamdring. Gandalf's sword.
That is a good one.
Cool. But he's my favorite character.
Yeah, so he is the best one.
There you go. Well, so let's get into business now. Anduril has gone from sort of a startup to this $61 billion defense tech company in less than a decade. Over that time, what's changed? Is it the technology, the threat environment, the geopolitics, all of it? What do you think has been some of the biggest factors that have driven that growth?
Yeah, I mean, so go back to 2017, right? It was kind of the end of the counterterrorism era. The view was that, when we started this, everyone was like, well, there's never going to be wars again. Why would you even work on this? The idea that China was an adversary was highly controversial. And so it was a very, very different time when we started the company. And you kind of fast forward through a couple of different things happening that I think all converged to make us accelerate a lot faster than we anticipated. Number one was the geopolitical shifts. I think this is probably the biggest. So U.S. pivot to China caused them to really look at whether the force structure and the way they were operating was going to be successful. And I think the conclusions when they went through that were kind of not great, right? Like, aircraft carriers highly at risk, a lot of the air platforms highly at risk. So it's a really hard problem. So there's a huge relook in the military side. Then on the geopolitical front, you had the conflict with Ukraine, the prominence of, kind of drones, and you have the Iranian Shahed drones, which are effectively low-cost cruise missiles that are creating a huge amount of issues. So you had all these geopolitical and military technology shifts. And then combined with that, you had 2 decades of consolidation and just frustration with the current system. So a lot of the traditional contractors, just if you were to run any betting market on this, like what's the odds that this program is going to be over budget, late, and not meet what we wanted, is like everyone knows about 100%. So there's the amount of frustration in the system that the government wasn't getting, best value for money or getting things in a timely way was really, really high, right? And so the opening to try something different was there. So I think all those things converged in a way that, we were able to be there, started it when it was highly unpopular to do defense. All our VCs had to change their LP agreements to get people to allow them to invest in defense. Like it was just not allowed. It was only a couple of years ago that we could even have European investors. So it was a very, very different time. And, doing something when it's unpopular tends to be a pretty good time to do it because no one else is doing it, right? And you get the first mover advantage. So it worked out quite well. We've made an immense amount of progress, and I think fundamentally we've been able to just deliver. Like my read is delivery is the most scarce thing in defense. If you just deliver on time, do what you say, it's really good. It's really rare, and so it's just a different environment than I think a lot of these competitive tech environments where just executing well and being in there at the right time made a huge difference.
How would you describe what you do? Because partly it's around weapons and the hardware, but there's also a software component to what you do. So what's the best way to describe, what exactly Anduril does and how you're a tech company or a tech defense company rather than just sort of a pure play defense company?
Yeah. So a big part of this is, play it forward 20, 30 years. It feels inevitably true that the vast majority of aircraft, of ships, of land vehicles, like these things have to be more autonomous and less crewed. And you're just going to have this inevitable shift that occurs where it's going to be more robotic. And with that, its sensors are getting cheaper. The number, cost to orbit is cheaper. The cost to build a new aircraft is going to go down even more with AI. So all these, the ability to introduce new platforms goes up. The cost to manufacture them is going to come down. And so the reality is you're going to have thousands and thousands of systems on the battlefield. That is an overwhelming amount of information. It is nearly impossible for humans to coordinate that and understand what is going on. And so we've built a lot of software around what we call it Lattice, but really the idea is what does that operating system and infrastructure to enable this modern connected battlefield really look like? And, how do we fuse in autonomy and all these different aspects to it so that humans can do what they're really good at, which is make, kind of high consequence, high contextual decisions. And we take a lot of the more mechanical aspects and, pull it all together. So we've infused, AI into every level of this. How do we process sensor data? How do we surface up the right decisions for humans to make? If we networked everything, we've made it all sort of very resilient, very interconnected. And so that foundational tech has really mattered, and it enables us to bring really sophisticated systems to bear quickly, where we can make a relatively simple cruise missile, say, for example. But we can just load it with this advanced software immediately and constantly enhance it and refine it over time.
When people think of, AI and autonomy when it comes to weaponry, people sort of, I think, have this idea of weapons that sort of can carry out attacks on their own, for example, or, very little human supervision. And there's this sort of idea around it. When we talk about AI and autonomous weaponry, what exactly are we talking about from your point of view?
So there's nobody wants the insane version of this. Like nobody in the military is talking about it. Nobody thinks it's a good idea. But the reality is we already have lethal autonomous weapons. They exist. So you think about like a torpedo. How does a torpedo work? You say, here's a region, and if anything looks like it matches this acoustic signature in this region, that's a military target. We have anti-radiation weapons, where the idea is if I shoot a missile at an area, if it's something is emitting in that area that looks like a Russian radar, that's a military target. So these have existed since like the 1970s, right? This idea that you're going to have machines in a bounded way make decisions, but you know what they're going to do. They're going to be predictable, and you can kind of constrain them in a smart way. That's always been true. Like that's been true for a very long time. And AI enables you to make this more precise, more discriminating, more accurate. So, the counter view of, well, we shouldn't have AI in weapons to me is just a deeply unethical view where you're saying, oh, actually, we should have dumber weapons. We should have weapons that don't make smart decisions. You're like, well, that seems like a strictly worse world to live in. But you want to put the right bounds on it, right? And you want to say these things are still controlled by accountable people. And we still have the mechanisms to say these are predictable, they're tested, we know what they're going to do. They just are smarter. And so you're just talking about a sliding scale of really how much discretion do we give it. The other dimension to this is you just look at the volume of strikes that the U.S. had to conduct in the Iranian conflict, or how much Ukraine is conducting. That is an overwhelming amount of decisions that are being made every day. Using AI, where you have the best reviewer possible looking at your decisions and, kind of calling out errors in your decision making, that seems like, again, a very ethical, responsible thing to do. But again, the idea is fundamentally the AI is there as a tool for the human decision makers. The AI is not a person. Like the AI is not making these decisions. It is about enabling humans to make better decisions because the military has a system that the battlefield commanders are accountable and responsible for what happens for their employment of weapons. And that is a good system. We like that system. And so AI can massively enhance the precision that they can operate at.
You said no one wants the insane version of this, and no doubt. And so when you think about what you build at Anduril, is there a red line or something that we just won't ever build?
Yeah, so like the fundamental thing is we have principles around how we think this should work, right? Which is very much around human supervision of decision making, robust independent evaluation that we have internally of how the systems are actually performing. There's kind of a set of guiding principles around these things. Then our responsibility as technologists is to also say when something's just not going to work, right? So, we've had people come to us and say, hey, I want to do facial recognition from 5 kilometers away. And we're like, it just literally won't work. It will not be responsive. We can't responsibly do this. The error rate's too high. This isn't going to give you what you want. Like, this is not a good idea. And so our view of this is, we do not want tech bros in charge of making military decisions. Like, it seems really nice. It seems great to say all these things, but we're not actually responsible for the safety and security of the nation. And when you are responsible for that, the decisions are a lot more gray and a lot more difficult. So me being here and pontificating about all the ethics, it's great. It's talking from the cheap seats. The reality is we need to be responsible as technologists, and then the elected officials are actually the ones accountable for making these hard decisions. And we need to empower them with the best information. We need to do it responsibly. But fundamentally, our view is, tech people articulating their philosophical positions on how national security should be done, it should count for about zero.
When people hear the phrase AI in war, they're often thinking about autonomous robots making these life and death decisions on their own. But that isn't actually where the transformation is happening. Increasingly, AI is sort of becoming this operating system of the modern battlefield, helping militaries process enormous amounts of information and coordinate these complex operations that humans alone simply can't. But the human is there, of course, making those decisions, being formed by those decisions as well. So if we think about AI, that could mean connecting thousands of drones, aircraft, ships, all of this different data, processing it, bringing it all together, and understand what's happening to allow militaries to respond far more quickly than before. And again, those recent conflicts we've mentioned before, including Ukraine, have highlighted why this matters. Cheap drones, constant surveillance, overwhelming volumes of battlefield data have made modern warfare dramatically more complex. And the challenge is no longer collecting the information. It really is sort of making sense of it fast enough to act. And I think as that complexity grows, that's where greater autonomy becomes less of a choice, really, more of an operational necessity, not because militaries necessarily want to remove humans from the decision-making process, but because they simply can't keep pace with what's happening, that scale of modern conflict, really. And of course, that doesn't mean AI is going to replace human judgment. Instead, I think one of the biggest questions facing militaries right now is to actually where to draw the line. At what point does this sort of AI go too far? How much authority should AI have? Which decisions should always remain with humans? And ultimately, who is accountable when AI becomes part of that decision-making process? Those are exactly the kind of questions that companies like Anduril are now helping governments to grapple with. So beyond AI in sort of the weapons themselves, how is Anduril as a company using AI in things like weapons development? There's been so many advances on models, and we're talking about digital twins, this idea of being able to create a digital world that represents and test things in that digital world before they get to real life. So many different parts of manufacturing, design have emerged in the world of AI. How much AI are you using in terms of actually designing weaponry and future products?
So there's the obvious, kind of, coding agents and all of that. We've been heavily adopting that. I've was talking with another tech CEO who was just like, no, dude, I'm a coder again. It's great. So I've got like 3 Claude code sessions ripping right now. It's great. So that side's kind of a no-brainer, but then we're seeing a ton of progress on both the mechanical electrical design. So the ability to very rapidly do all the analysis tools that would take like a cluster of machines 2 weeks to run, like computational fluid dynamics or anything. There are 3 different companies making AI enhanced versions of this that simplify the process and run it about 1,000 times faster for 99% of the accuracy. So it's great. We're seeing a ton on the manufacturing side. There's 3 different startups that we're working with that are applying AI, like work instructions are one of the most tedious things to construct. You literally have like highly trained engineers who are sitting there like generating PowerPoints by like blowing out CAD drawings. You're like, okay, this is like no-brainer AI automation. So the ability to rapidly introduce new products, to, kind of get all of the coordinated, work instructions, bill of process, all those things on the manufacturing side is massive. So we're seeing it kind of across the board where we're seeing a ton of benefit there. And then the amount you can collect on just like telemetry of how your systems are performing, and then to be able to actually mine that efficiently, I can contrast it to what you have to do normally, where it's like an engineer has a hypothesis that takes them 2 days to run down. Great. Now I can spin up 200 hypotheses that this thing is generating, that it's constantly running down to assess, are my systems working? Where are the reliability issues? Anything like that. So it is just the volume of work that you can accomplish, the amount of leverage you can get on the engineers and production folks in terms of what they're able to do, where they were just constrained by hours in the day before. It's just massive.
You mentioned manufacturing as an area where sort of AI, you are seeing positive impacts from that. You've got huge manufacturing capabilities over in the US. What are you doing differently in terms of manufacturing with Anduril versus, historically how defense companies have operated? Is it around cost and automation?
Yeah.
Where are you trying to see, position yourself differently?
Yeah. The biggest thing is supply chain, and it's really who you pick in your supply chain. And so the traditional defense world has been, kind of these high pedigree modules that you assemble into, so you get your avionics module, you get your actuator module, right? And these things are kind of very slow to change, relatively low volume, very expensive. But in this uncrewed world, in this autonomous world, it doesn't need to have as much pedigree, right? Like you can take a little more risk on what these things are. And so we've really pushed hard on pulling a lot of the design in-house. So we design our own avionics, we design our own actuators, and then that allows us to now go out to a much broader base of suppliers, where I can work with the folks supplying, automotive, right, on metallic parts, circuit boards, on composites, like all these different things, and be able to tap into a much larger supply base that is, kind of more commercially viable, taking on best practices in more competitive environments. And that's been huge because that enables us to scale very, very quickly, where we can, tap into this much bigger and much more responsive supply base than I think has typically been available in defense and aerospace. So that's been a great kind of strategy for us. And then you have a bunch of defense exotic stuff, like when you start talking about like solid rocket motors and exotic infrared detectors, like those are things that just like there isn't a commercial supply base for. Those we've largely pulled in-house. And so we've acquired a company that does solid rocket motors, advanced imaging technologies, electronic warfare pieces. We've pulled a lot of those in-house, and we do a lot of that production ourselves. And so it's enabled us to control our destiny on this, where we can invest in the capacity that we need. We can bring more automation to the process, like all of those things that have really started to pay out for us. Because just being able to assure that you have the supply to ramp quickly is really key. So like we just signed a contract with the Pentagon to ramp from basically 0 to 1,000 cruise missiles in a year. It's 1,000 a year minimum for 3 years. 1,000 will be more cruise missiles than have like ever been produced in the history of cruise missiles. So like we are just like the amount that we're like sort of producing very, very quickly is, I think, enabled by the fact that we've thought about the scalability of supply chain so much. And that's the biggest aspect of it.
To use a slightly crude analogy, I mean, when you look in the consumer electronics space, a company like Apple, right? And we talk about owning your stack, right? Owning as much of the technology that goes into your products on both the hardware and software side, as much as you can. Is that a similar kind of model you're trying to replicate?
Yeah, I think the control your destiny is probably the right way to think of it. In the defense world, it ends up a little bit more, you can't run the walled garden strategy that Apple does, right? It's just not going to be possible. You end up kind of living in more of an Android world no matter what. On the software side, you're always integrating with other people's hardware, and that's great. We love it, right? And that's a key part of the strategy. So being kind of open and accessible like has worked, right? So we run our software on other people's hardware. We run our hardware as other people's software. That's fine. We'll make it work. But I think from the manufacturing and production side, that degree of having the option to control your supply chain, your scalability, that's critical.
On a specific component, semiconductors in particular, there's all different types of flavors of semiconductors that go into weaponry.
Yep.
How much of the semiconductor stack are you focusing on within Anduril? Are you looking to design as many of the chips that you use, or are you happy with kind of third-party suppliers?
I mean, when it comes to the AI space, we could spend, any amount of money, and the world will be exactly the same place in 5 years, right? It's like it's just the reality is it's like NVIDIA, all the inference chip investments, all these things so far surpass anything that we could plausibly do, that we're much better off as a taker of what actually works. Because the other reality with defense is the volumes are quite small. So it's like, okay, so say we make 1,000 cruise missiles, or probably like we'll make 5,000 or 6,000 next year. That is not a large number by any like consumer standard. So we invariably end up in this sort of like higher mix, lower volume world. So like custom chips can pay out. We do it where we have to. We do a bunch of custom silicon. But on the whole, if you're much better off taking commercial options when they work.
When it comes to sort of the supply chain as well, as you look at it, when we look kind of globally, there are bottlenecks all over the place in various supply chains. I mean, you look in terms of what's happening in data centers, you look at memory, for example, as a key bottleneck, the manufacturing capabilities out of some of the semiconductor factories and fabs. Where are the supply chain bottlenecks right now in your industry? I know rare earths has become a huge talking point geopolitically,
right,
as well. What for you are you seeing as key flashpoints here?
Yeah, so we're subjected to the same demand pressure or supply pressure on DDR4 and 5 memory, all these things like SSDs. It's a mess. The reality there though is that particularly in the U.S., they have a system that puts defense orders at the front of the queue. That's just kind of how it works. It's great. So that part's maybe slightly less problematic for us, or is more solvable just via kind of policy. The much, much bigger issue is that China has intentionally taken a strategy over decades of strategically choke pointing key supply chain items. So the rare earth magnets is one that came up, during the trade negotiations. that they basically have locked down export of magnet manufacturing technologies, as well as controlling the outflows of those magnets as a negotiating lever. Well, that's one of probably about 30 things they're doing this on. Another one that's come up is germanium. We use this for infrared lenses. It's used in a lot of other semiconductor processes. We've had to work with the Pentagon and other sources to identify long-term supply of this and to help facilitate more capacity in the industry. Titanium, hafnium, there's all these weird kind of components in this. Also while China was doing that rare earth negotiation strategy, right, on the trade negotiations, they were also buying up the independent suppliers of copper film that's used on PCBAs. So there was 3 independent ones that weren't Chinese owned, 2 in Europe, 1 in the US. They bought up the European ones. And then they tried to buy the US one, but that was blocked by, kind of the CFIUS regulations. So they are taking a very active and very intentional strategy to do this. We've seen them using their leverage on battery suppliers to prevent them from selling to U.S. defense, right? So if they're a commercial battery supplier, they're probably getting, kind of some of the core precursors from China. China is saying you can't use that. And so they are exerting their leverage in a lot of ways, and it's been a very intentional strategy. I think the Western world has woken up to this reality that China was not playing the same game of free trade and all these things that the rest of us were hoping everyone would play, and is starting to look much more strategically about where does industrial policy come in for creating resilience.
But 2 follow-ups. One, does the US and allies, do you think, have access at this point to the rare earths and the various components that are required over the long term? And 2, I mean, it is also, we've seen, while China has been sort of carrying out these actions, we've seen on the US front as well, various restrictions on technology, semiconductors, various other things to China as well. Much of that has been focused around military. A lot of the reasoning given by the US government over the past few years has been, we don't want this technology to fall into the hands of the Chinese military, whether it's advanced semiconductors or anything else. So there has been a sort of, to some extent, a tit for tat around this geopolitical story, right?
Yeah. And this has been part of the deal where, sort of if you're in the Western alliance and you play by the rules, you get one set of treatments around what you get access to. And if you are not, then you get a different set of treatment. That's part of the deal. So I don't think China's playing a bad strategy on this. I think it's a very effective strategy, as we've seen, right? They got a much better deal than they could have if they didn't have this leverage. So I think they will continue to do this, and in the U.S. and the allies will continue to do the opposite, and we should, right? That's the game. In terms of access, I mean, I think it exists. So you take like a lot of the rare earth magnets, a lot of the most productive mines are in Australia, right, and then they're processed in China. And so the refining and processing side is what they've understood that they need to control for. Then a lot of the Western democracies were very happy to outsource that because it's kind of a, maybe a little more of a dirty process or, like less, margin stack in it or something like that. But the reality is the supply exists. It is the processing side that needs to be reconstructed. And so that's where I think more supply needs to be built up. So I'm not that concerned that it can be done. It is just not a trivial investment. And then you have to take seriously that they are overcapacitizing and undercutting the market as an intentional strategy. So this is not something that the free market alone just fixes. It's just not going to work because they're not doing free market economics, right? They're doing it below cost. And so there has to be a realization that there's some amount of protective measures combined with some amount of, kind of offtake and demand stimulation that has to exist to actually get to the other side of this.
Before we go further, I think it's worth stepping back because I want to tackle a term, and this is a term you're going to hear not just in the context of this defense discussion, but with some of the other conversations we'll have, and that is sovereignty. Whether it's tech sovereignty or defense sovereignty, the focus from governments right now is around how to control or have oversight over more of supply chains. In technology, that's incredibly acute right now. We had this sort of world where globalization was just accepted as the norm and there was free trade and you could source components from any countries and make products elsewhere, get those products to your own country. But actually, What's happened now is governments are beginning to identify critical technologies. Defense is certainly one of them. Things like semiconductors, AI, etc. And what that means in the world of technology and in the world of defense is that countries want to secure more of the supply chain. And by that, I mean the actual materials that go into building these systems. That could be rare earth metals, that could be other kinds of components as well. And increasingly, countries want those products, weaponry, for example, or other technology, to be built on their soil so that they have a view of it, that they have access to it. And so there is a lot more manufacturing that is being built up around these types of components, like semiconductors, like weapons. It's why you're seeing countries trying to build loads of data centers on their own land, because they want to make sure that data is being processed on or within their borders. And so this becomes interesting when you talk about weaponry, because modern defense technology is so complex. Different components, semiconductors, sensors, batteries, rare earth magnets, motors, dozens of critical materials. And in many cases, those supply chains are concentrated in just a handful of countries. So the challenge isn't where raw materials are necessarily mined, but where they're processed, refined, and turned into usable components. And that means this isn't just a question of where you're building those weapons. It's about whether you can build all of those with all the geopolitical relationships that are happening, and if those deteriorate or take a different kind of turn. And that's why this sovereignty debate is so front and center. It doesn't mean you can make everything domestically, but it is certainly more about trying to control more of that supply chain. And I think for companies like Anduril, this changes the equation, particularly as they're starting to think more like fast-paced tech and electronics companies as well. It's not just about building sort of smarter software or better drones necessarily. It's about combining all of that hardware, software, the manufacturing capabilities, and that supply chain into a sort of a defense industrial base that they can respond when it's needed most. Ryan, for the last part of this conversation, I want to talk about Anduril's business going forward. And first, just how you're expanding in a world where tech sovereignty and sovereignty more broadly has become a real big buzzword amongst governments. I think particularly here in Europe, we hear it a lot about sovereignty, whether it's around AI, whether it's around cloud, whether it's around defense. And this push, particularly in Europe, for trying to go with European suppliers and building out European capacity in various areas, where you're seeing this sort of growing trend and desire for sovereignty around all these areas. How is a company like Anduril from the US talking to some of these governments who are really keen on sovereignty?
There's an emotional angle and a pragmatic angle. And so the, kind of pragmatic angle in favor of sovereignty is, you want to assure that you can expend capital to get weapons. That seems like a good thing you should have for your defense industrial base. If you are, unsure where you're going to fall in the queue, how long it will take to get your stuff, that is not a great place to live. And so this, one dimension we've seen of this is, hey, the ability to own production, to have co-production sort of arrangements. That's kind of one flavor of this that plays out. Then I think you get to this other pragmatic question, which is, can a European, the idea that there will be a European market for defense is just not true. Nobody believes it. People talk about it. It's just not true. Because what I've seen is that it is, what's less offensive, Germany buying from France or the U.S., right? It's just obviously it's less offensive to buy from the U.S. And so what every country has been trying to do is build their own defense industrial base. Europe is so fractured. And say you want to build a air and missile defense, system. Well, you're talking about 4 different weapons programs, an advanced software program to fuse all these together, advanced sensors. Very few countries can afford to execute that at the scale and complexity necessary to build these modern systems. Let alone you start talking about full space constellations, communications networks, targeting ability. No one country is going to be able to afford it. And so the reality is that you've got to find a way to get access to the best technology while having the ability to sever it if relationships deteriorate, right? So that's a very achievable thing, right? Because like in a modern world, you start talking about, okay, I've got, Anduril UK, really straightforward, right? We can clone the source code here. That's totally fine. And if the US and UK relations, or they just even disagree on what the priority of features are, which is pretty common, great. That's fine, right? Like, we've got the source code and we've got the engineers here. And so that model of having the sort of local sovereign, kind of entities that are being able to share the technology across, move up that technology curve while still retaining the optionality to produce what they need to produce and go their own way when they need to go their own way. That feels to me a much healthier model. Whereas right now, it's being framed in this very binary way.
So is that Anduril's sort of plan over the longer term, build up local boots on the ground in terms of offices and people here to talk, and in various countries where you want to operate? And does manufacturing follow?
Yeah, the manufacturing is often, I think, going to be more often than not the leading thing, where it may be a design we've already made, but they want to do licensed production or co-production of this. Yeah. And sometimes that'll be an Anduril office, that'll be Anduril run, and that's great. We'll do a contract with the government there. And in other cases, it's going to be through partners, all right? And it's just, every nation has a very different strategy of how they've thought about or want to think about the defense industrial base they're creating, what control they want to have. Some are state-owned, some are pseudo-state-owned and single provider. Some are more competitive environments, that are either open to foreign participants or just actually de facto closed to foreign participants. And so each country's just got to have its view of what matters, what control do they need to have. But I think the pragmatic view is they need access to the best technology. And it is too expensive and too long to redevelop all of this over time.
Are you having those conversations right now with European countries in terms of manufacturing Anduril product in Europe, either as a partnership with current manufacturers or own facilities?
Mm-hmm. Yeah, no, we've got, about 150 people in the UK where we're doing more of the, full participant in the ecosystem, doing novel development here. In Europe, it's been a lot of different conversations with, nearly every country around, what's interesting, what does it look like, where would we partner, where would we, kind of build our own thing up, where would it just be traditional U.S. defense exports? All of those are on the table. So we've been, kind of approaching a lot of different angles with this, and we're quite flexible and quite pragmatic with it. I mean, it's just too hard to have one rule for this. Like, every country's correctly got its own view of how they need their national security to work.
Give me, I think earlier in the conversation, you were talking about the production ramp up of some of the cruise missiles, particularly for next year. What does that production ramp up and the demand mean for Anduril's growth sort of over this year and the following year? What are you seeing in terms of growth? Can you give me any kind of projections or expectations you have?
We have, I think this year, between last year and this year, I think we're going to see something like a 400% increase in production revenue. I think we probably don't keep going at 400%. That would be very hard. But we'll see over 100% growth year over year for the next,
in terms of revenue growth.
Yeah, like that. And the production volumes will increase tremendously, and a wide list of SKUs. So we're seeing just a very aggressive ramp on that front. We'll probably end the year around like 12,000 people. Like, it's gotten to be quite sizable, quite fast. Most of that growth is happening in the U.S., and they've just been adopting at scale very, very quickly. They've been kind of that pivot to next generation technologies and then catalyzing budgets and contracts behind that, really started in earnest about 6 years ago. And so that's really now kind of percolating through, be it, air defense, strike weapons, autonomous aircraft, any of those things. Like, those are really all ramping at once for us right now.
Brian, it's been a pleasure speaking with you. Thanks for joining me.
Thank you.
Let me know what you thought of this episode, or if you just want to discuss the Lord of the Rings, you can reach out to us on the tech download at cnbc.com. You can also reach out to me directly. I'm on X, TikTok, Instagram, LinkedIn. Search for me at Arjun Kharpal. Thanks for listening and watching, and we'll see you next time.